Hi everyone, I'm Randy Kolka. I'm a research soil scientist with the USA Forest Service Northern Research Station in Grand Rapids, Minnesota. Welcome to Marcel Experimental Forest. We're going to talk about bogs and fens today. At first we're going to go in the classroom for a little bit and talk about specifics on sort of the functions of peatlands and the introduction to Marcel. Now we're going to head out to the field and we're going to go check out a bog and a fen. All right, we're inside now, and I want to give you a little presentation on sort of an introduction to Marcel Experimental Forest and peatland environments before we actually go out and see a peatland, actually two of them, a bog and a fen. Marcel Experimental Forest, like I said, outside has been here for about 60 years. And within Forest Service, we have about 80 experimental forests. About 70 of them are for growing trees bigger, faster, better, straighter. It's all about growing trees. About 10 of them are like Marcel, where we're watershed-based experimental forests, actually much like Robinson Forest, where we look at management effects on water quality and quantity, basically. Back in 1960, we really didn't know much about these ecosystems. So original studies were really understanding peatland hydrology and soils and ecology of these ecosystems. In the late 60s and early 70s until recently, we've been looking at forest management effects by doing different harvesting and other kind of practices in the watersheds, look at water chemistry and quality and quantity. And then in the 70s, acid rain days hit, and we really started looking at biogeochemical cycling, especially the cycling of sulfur and nitrogen. And then about that same time, a little bit later, we started thinking about mercury cycling. Mercury is a whole nother topic. It's a bad pollutant that bioaccumulates in the food chain. Wetlands are a really important component of that cycle. And then about 1990, we were already starting to see things change up here from a temperature point of view. So we really started looking at climate change and carbon cycles. And you can see the different watersheds on the Marcel Experimental Forest here. We got a north unit and a south unit. And each of the units are labeled S1 through S6. S stands for swamp, because back when we named them in 1960, we didn't know that there was bogs and fens. We just called them all swamps. So we keep that lexicon and remember where we came from. And you can see our temperature record here. We've been up about 3 degrees Fahrenheit in the last about 58 years in this case. We don't have the last year or two. But what that leads to here in northern Minnesota is about a 3-week longer growing season than we had in 1960. So things are changing up here. We measure lots of different things, and you can see the list of things here. I'm not going to go through them. But much like, again, Robinson Forest, we measure stream flow and chemistry, as well as all the climate variables. We're up to many, many dissertations and many, many papers, and that's our website if you want to look any further. To the extent that in about 2010, we decided to pull the band back together from all the way back to 1960. We were losing some of our institutional knowledge, and we developed a synthesis, a compendium basically, of everything we've ever learned at Marcel, and put it all together in one book. So when we get a new person, a new scientist, new graduate student, new faculty member that wants to work with us, we got a copy of this book to get them up to speed. So with that introduction to Marcel and peatlands, let's talk a little bit about peatlands. Peatlands are really, in one simple way, it's a balance between the decomposition of vegetation and the production of vegetation. And over 10,000 years since our last glacial period here, production has outweighed decomposition just by a little bit. And if that just outweighs decomposition by a little bit, you can get tens of meters of peat built up over 10,000 years. A couple of different ways peatlands form. One's called an ice block depression. And that is when a big hunk of ice calved off the front of the glacier and maybe was covered up with sediment or was run over by the glacier back and forth. But after the glaciers retreated, there was ice trapped in the soil, basically. And these could be huge pieces of ice. And when the glaciers retreated far enough and things warmed up, that ice, of course, melted and created a depression with water in it. And that can be the start of a peatland, or many of the lakes here in Minnesota. And so as peatlands developed, the shoreline started filling in with vegetation, cattails, that sort of thing. And sooner or later, the whole peatland filled in, and or the whole water body filled in and became a terrestrial environment. And so that process going from ice block depressions is called terrestrialization, basically making terrestrial environments. The other way peatlands form is through pollutification. That's when you have a water limiting layer in the soil that doesn't allow water to penetrate very readily. So it ponds water, and anywhere you're going to pond water, you start building up organic matter. And in this case, that's the way many of the peatlands also began. Peatlands are also important for a lot of functions. They're really important carbon sinks on the globe. They're really important from a hydrological and a water quality point of view, and they're really important habitat for both flora and fauna. Really neat stat that I like to show is that from a carbon sink point of view, they only occupy about 3% of the planet, the terrestrial zone of the planet, but they store 30% of the soil carbon. So really disproportionately important from a carbon point of view, but really makes them important from a carbon cycle point of view with regards to climate change as well. Numerous studies indicate that they continue to be sinks for carbon, which is good, really good. But there's also studies that are saying that they're not as much sinks as they used to be, and even flipping to be sources, which can have big ramifications on our global climate. So there's two types of peatlands. Well, there's more than that really. But two ends of the spectrum, there's bogs and there's fens. There are a few environments in between bogs and fens, but it's very a bimodal population of two different kinds of peatlands when you look at peatlands across the globe. We'll talk about the differences here in a minute. Okay, so one of the fundamental differences between bogs and fens are connected to the regional groundwater and bogs are not. Bogs are only fed by precipitation and a little bit of upland water coming through the lag, and I'll tell you what a lag is when we get out in the field. They're a really important part of the hydrologic system of bogs. As far as bogs, peatland functions, they're usually a function of that terrestrialization process, filling in of the lakes that were here after glaciation. They're much lower pH. pH is somewhere, between 3.5 and 4.5. I mean, we have bogs out here that have pHs at 3.5, the pore water is in the soils. Really low in nutrients, especially nitrogen. They have high carbon in the streams that leave them. The waters are essentially black because of dissolved carbon that's in the waters. They have a lot lower flow because they're small, but they're numerous. They dot the landscape. That's where all those ice block depressions were following glaciation, is where the bogs are now. Another interesting part of them is they're domed. Productivity in the middle has outpaced productivity on the edges, creating a dome environment, which creates this lag that goes around the bog that we'll talk about again when we get in the field. Whereas fens are usually a result of that pollutification process, that limiting layer in the soil that don't let water go through. Much higher pH because they're connected to regional groundwater, 6.5, 7 in Minnesota. A lot higher in nutrients, a lot lower in carbon, but they have a lot more flow. And so the streams coming out of fens are relatively clear, but they have a lot higher flow because they're connected to the regional water table. There are fewer, but they can be huge expanses. In northern Minnesota, we have different places where we have thousands of acres of continuous fens. And they're not domed because they have this groundwater influence. As far as vegetation, bogs are generally forested, but not always. The two species up here that can handle the bog conditions are black spruce and tamarack, or eastern larch. They're very much sphagnum-based, sphagnum moss-based. The reason that they're here is because much of the organic matter in the bogs is a result of sphagnum decomposition. They have some ericaceous shrubs, small shrubs. Labrador tea, leatherleaf are just a couple of examples, but there's a few more. But another interesting component of bogs is they're the ecosystems that have the bug-eating plants because they are so low in nitrogen. And so in our ecosystems here, we got both pitcher plants and sundew. The pitcher plant is this one right here, and the sundew is this one right here. Whereas fens, they can be forested or unforested, much like bogs, and they're also sphagnum-based. They have pretty much all the bog plants, but then they got many more, much more diverse. In a bog, you might have 10 different species, for example, of plants, whereas in a fen, you might have 40 or 50 different species out there, and we'll see that later. And some examples of this are the cedar swamps, the birch and black ash swamps that we have up here in northern Minnesota. Again, numerous sedges, ferns, and other ground flora in Fens. So the other functions are habitat for various flora and fauna. A lot of things that are endangered and only these habitats. They're a great place for white-tailed deer in the winter because they're so insulated systems that deer like to be congregating in those warmer environments in the winter. This is the moccasin flower. This is Minnesota state flower, generally found in peatlands. Wood frog, wood turtle. And this is a boreal chickadee, not a black-capped chickadee like most of us have. This chickadee pretty much his whole entire life lives in a bog. Matter of fact, they make their nests out of the sphagnum from the bog. So, really interesting species that does come down in northern Minnesota from Canada. So just to recap, peatland formation is two different processes, terrestrialization and polludification. Peatland functions related to carbon, hydrology, bogs and fens. Remember, the bogs are only precipitation fed, and the fens are connected to the regional water table. Remember, the bogs are generally produced through the terrestrialization process, and fens through the polludification process. And of course, we just talked a little bit about important habitat as well. So, we're going to gather up our things, and we're going to out in the field, and we're going to go to a typical bog and a typical fen, and we'll talk about the differences in the field now. So now we're out in the field. We're going to visit a bog first. This is the S2 bog. It's one of our control or reference systems for the Marcel experimental forest. And the first thing before we get to the bog, we're going to go through the lag zone. I mentioned the lag back in the classroom. The lag is an area of the bog that's really important from a hydrological and biogeochemical point of view. As I mentioned, the bogs are domed behind me, and so the water runs from the top of the dome of the bog, and they're only domed maybe a foot or so, about 20 centimeters maybe at the most. And so the water runs off the top of the bog down to this zone here, which is the low spot in the landscape, the lag. And of course we have upland waters running down to this zone in the lag as well. And there's a mixing of bog waters and upland waters, which really makes this an important area because it's a little more nutrient rich than the bog proper. And so we have this zone, it's kind of narrow, where these waters mix. It's a biogeochemical hotspot, where we have more methane, more nitrogen dioxide, more other things going on here from a biogeochemical point of view because of these mixings of these two various different waters. The other thing it has a lot to do with is the plant communities. Here the plant communities are very much like the fen because of the upland waters are more nutrient rich. You'll have a lot more diversity, and as we start moving into the bog, you'll see we start losing that diversity of the plant community. Here we got some birch, some other hardwoods, and as we get to the bog proper, we start to see pretty much a closed canopy of black spruce. And then that closed canopy of black spruce goes all the way up to the dome in the middle. And so we have the black spruce in the middle, in the dome, and then on the edges we have the lag. And it's the lag zone on both sides of the bogs where most of the water flows, and that's what coalesces downstream to actually develop into a stream that leaves the watershed, and that's where we measure flow and chemistry at the weir downstream from here. So one of the things, again, I mentioned back in the classroom is how nutrient poor these bog ecosystems are. Really low in nitrogen, really low in pH, so there's not a lot of plants that can grow here. Like I mentioned, one of those plants is black spruce. Believe it or not, these black spruce that are maybe 4 to 5 inches in diameter are over 160 years old. So that's how slow plants grow out here because of the nutrient, lack of nutrients, like I said, especially nitrogen. One of the other thing that grows out here because of that lack of nitrogen is the carnivorous plants, the bug-eating plants. And this is a pitcher plant right here. And as you can see, they are full of water right now. What the pitcher plant does is it has hairs that point downward into the plant, and when a bug lands on those hairs, it slips into the pitcher of water, basically. And then it dissolves in the water, and that's how the plant gets its nutrients. Similarly, we have sundew out here, which is a really hard plant to find because it's so small, but it has stickiness to its leaves, and a bug gets stuck on the stickiness of the leaves fold in and it starts decomposing it inside the leaf. So that's the two mechanisms by which these two plants acquire their nitrogen. So now we're at the dome of the bog, in the center of the bog here. And again, I want to talk a little bit more about the vegetation out here in the center. There's very few species out here. You can see still one of the black spruces that's only about 4 or 5 inches in diameter. We have some ericaceous shrubs here, including the Labrador tea. We have a few other species. We had a cranberry out here. This is the cranberry. It is a really small plant that actually has a cranberry about the size of your thumb, and it just puts all its resources into the berry itself instead of into the leaves, because it has to have the seeds to propagate the next generation. Actually, here is one of those cranberries. So you can see how big they are in comparison to the plant themselves. Out here in the middle, the Pedan in this bog is about 7.5 meters deep, so about 22, 23, 24 feet. And that's built up over time since the last glaciation here. And very slowly, but even slow processes over time can build up massive amounts of peat, organic soils. And that's because they have very slow decomposition. And this is a good example of that. We took this cookie out of a bog next door to us here, and it was down about 5 or 6 feet. We were trying to install some instrumentation. We had to cut the cookie out and we brought it up, and we carbon dated it, and it was about 5,000 years old. And so much like in Northern Europe, you hear about the bogmen that have been preserved in some of the peatlands in Ireland and Scotland. Very slow decomposition. This is another example of that. It looks like it dropped in the woods just yesterday. Finally, out here in the middle, we also have a groundwater monitoring location. And so this is our bog well, and we look at the groundwater levels. And normally during this time of year in the bog, groundwater levels will be much lower than in the fen, which we'll see next. But we had just had 7 inches of rain in the last couple of weeks up here in northern Minnesota, so the water levels are very near the surface as we speak in the bog, which will be similar to the fen. But generally, because these are precipitation fed only versus groundwater fed fens, these systems would draw down in the summer. And thinking about precipitation fed, if we have changes in precipitation as a result of climate change, what ecosystem do you think is going to be most impacted? It would be the bog system, because that's the system that relies on precipitation. Okay, let's go check out the fen. So now we're just entering the S3 fen, and we're first going to just take a quick look at some of the vegetation. Got a much more diverse vegetation population here. We can see some maple trees, horsetail, a bunch of different ferns, marsh marigold, which is a very good indicator of fens. As we move down the boardwalk, mentioned the birch tree in the lag of the bog. We have birch trees here. Again, the lag zone with the nutrient-rich lag zone in the bog is very similar to the whole zone of the fen. And so as we move down the boardwalk here, we'll go check out the well for the fen and talk about the water tables here in just a sec. We talked about how nutrient poor the bog was. Relatively speaking, the fen is pretty nutrient rich because of that regional water table. Again, pH is maybe 6, 6.5, 7. We talked about how old the black spruce was in the bog, 150, 160, 165 years old it is. In this case, we harvested this fen about 1980. And so this black spruce here is only about 40 years old, and it's almost twice the size in diameter, indicating again, much more nutrient-rich system and a much more diverse system, as we just spoke about as we were entering the fen. Here we're at the groundwater well for the fen, and as I mentioned, we had a big rain, and usually the bog water tables would be lower than the fen at this point in time, and in fact they are a little bit, even with the big rain. As you can see here, the water table is very much at the surface, right at the top of the fen, whereas in the bog it was maybe an inch or two below the surface. So even with the big rain, the bog had a little lower water table. Again, out here you still see the diversity of vegetation in the middle like you saw at the edge. There's no lag because the fens are not domed in the middle like the bogs are. And so that's our introduction today to bogs and fens. Thanks for visiting with us at the Marcel Experimental Forest. I hope you have a good semester.